Hello, and welcome to the lecture on money and inflation. In today's lecture, I'm going to describe the classical dichotomy, explain monetary neutrality and the Fisher effect, which are part of the classical dichotomy, and then I'm going to explain the cause of inflation and its effects on the economy in the long run. The classical dichotomy is the theoretical separation of real and nominal variables. That is, nominal variables do not affect real variables in the long run. Nominal variables only affect nominal variables. You might recall from an earlier lecture that nominal variables are measured in monetary units. Real variables are measured in physical units. Monetary neutrality, which is part of the classical dichotomy, states that money does not have any effect on any real variables in the long run. Money can have an effect in the short run. However, in the long run, the classical dichotomy is a holding. If I were to increase the money supply, the only thing that would change would be nominal variables, like prices in the economy. So money growth is an increase in the money supply. Inflation is when the price level is increasing. Deflation is when the price level is decreasing. And disinflation is when the inflation rate is decreasing. So perhaps the inflation rate is 6% per year. And then the following year, it is 2% per year. This would be disinflation because 6% is inflation, 2% is inflation, but 2% is lower than 6%. Disinflation. Real growth, as we already know, is an increase in the real production. So in the economy, we are producing more goods and services. Here is the velocity equation, also called the quantity equation. V times m is equal to p times y, where velocity is how often money is exchanging hands. M is the money supply, P is the price level, and Y is real GDP. Let's note a couple things in this equation. Velocity has a bar over top of it. This is to indicate that the velocity of money is constant. This is an assumption. It is a good assumption, but it does not always hold true. But for the purpose of easy examination, we are going to hold velocity constant in most cases. P times Y, the price level multiplied by real GDP, is nominal GDP. So we could say V times M is equal to nominal GDP. Since we're holding velocity constant, we can approximate the percentage increases in these factors by saying money growth is approximately equal to inflation plus real growth. Now, we've already done this type of equation when we looked at production is equal to productivity times population. We've also seen how we can do this type of problem with accurate math. This is an estimate. What it's saying is that if I increase the left side by 10%, then I'm going to have to increase the right side by 10%. Again, this is an approximation. Imagine that real GDP increases by 5%. This means that the price level is going to increase by 5%. I want to note here that the price level is actually the dependent variable in this equation, because the money supply growth can be controlled, and real GDP is based on how much we are producing. The difference between the growth in the money supply and the real GDP growth will give us the inflation rate. So the increase in price level is inflation. Perhaps real GDP increases by 8%. In that case, the price level will increase by 2%, i.e., inflation will be 2%. If real GDP only increases by 2%, then inflation will be 8%. Notice that the price level is dependent on how much money there is per quantity of production, or per basket of production. Assuming that the velocity is constant, if we look at this equation, we can see that as I increase that money supply, if I keep my real GDP, or the number of baskets I'm producing, constant, then my price level will increase. Look at this equation on the left side. Essentially, what we are saying here, or what we're seeing, is dollars per basket of production. That sounds like a price, very similar to dollars per apple or dollars per sweater. But in this case, the basket is filled with apples and sweaters and cars and everything else that is produced in the economy. The price level is essentially an indication of the amount of dollars in the economy per basket of production. So let's take a look at some examples. Start with some simple ones. I'm going to double the money supply and keep the real GDP constant. What happens? Well, according to our estimation, where the growth in the money supply is going to be approximately the growth in the price plus the growth in the GDP, we can see if I doubled the money supply and I kept my real GDP constant, in order to keep these two sides equal, I am going to have to double my price. Let's keep the money supply constant and double the real GDP. If this is the case, then our price level is going to be 0.5. Right? Notice how that price level decreased. This, of course, would be deflation. So money, which is constant, I'm multiplying my price by 0.5, and therefore I'm multiplying my price, I'm keeping my money supply constant. I've doubled my real GDP. So in order to bring that right side back to constant, my price is going to increase by 50%. 0.5 times 2 equals 1. Let's double the money supply and double the real GDP. If this were the case, we can see that the money growth is equal to the real GDP growth, which means that the price level is going to be constant. This is a constant price level, or 0% inflation. So how do things work in reality? Well, in reality, the money supply increases faster than the real GDP. Ultimately, the money supply will increase perhaps at about 5%. Real GDP might increase at 3%. And if you look at the animation, we see that that money supply is growing a little bit faster than the GDP. Under this scenario, we would expect inflation to be 2%. And again, this is just an estimate. We could do an accurate calculation similar to what we did when we did production is equal to productivity multiplied by population. Again, when we're doing this type of calculation, one of the things that we know is that the inflation is actually the result. All right, this is what happens at the end. It is the dependent variable. Now, this equation, the estimate that is, works fairly well when our percentage changes are low. But what happens when we have higher percentage changes? 12% and 6%. If we were going to use our estimate, we would say that the price level should increase by 6%, or inflation is 6%. But if we actually used our accurate calculation, we would have 1.12 for an increase in the money supply. That would be our factor increase. Notice how we've taken our percentage increase of 12% and we've converted it into a factor increase of 1.12. My real GDP is increasing by 6%, so that is a factor increase of 1.06. And if I were to do this math to get the factor change for the price level, we would have 1.12 divided by 1.06. And that gives me 1.0566 repeating, or we could say 5.67%. Notice how it's not quite 6%. And the larger these numbers become, as far as percentage changes, the further away our accurate calculation is going to be from our estimate. I would recommend that you just get used to the accurate calculation in this particular type of equation. So let's do a quick example. Here we've got a country with a money supply of $2.8 billion and a nominal GDP of $11.4 billion per year. If the money supply increases to $3 billion and real GDP increases by 3%, what will be the inflation rate? And let's assume that velocity is constant. Well, we can do this all in one step, but I'm going to go ahead and do it in a couple of steps. First, we can get our factor change for the money supply. In this case, our factor change is 1.0714, which is equivalent to a 7.14% percent change. Going to our VM equals PY equation, I know that I am multiplying my velocity by 1 because I'm assuming that it is constant. I am going to take my money supply and multiply it by 1.0714. I'm going to try and solve for this X value. So this is the factor change in my price level. And I know that my factor change in my real GDP is 1.03. Doing this mathematics, since we know that VM is equal to PY, I can cancel out VM is equal to PY, and I end up with this equation. Solving for x, we see that the increase in the price level, or the inflation, if you'd rather call it, is 4.02%. Now here's a graph that shows us that velocity is indeed constant, more or less. Right? Velocity is about how many times a bill, a currency of some sort, changes hands. We could imagine that I were to buy something from Mary, and I give Mary $5. And then Mary takes that $5 bill and buys something from Tony and gives Tony that $5 bill. And then Tony buys something from Yuki for $5, gives Yuki that $5 bill. This $5 bill has now exchanged hands 3 times. The velocity is 3. 3 multiplied by 5 is 15. And P times Y, you might remember, is the nominal GDP. So we have actually just accounted for $15 worth of nominal production. We can also show this in a graph. So this is the quantity theory of money graph using money supply and money demand. And for my course in macroeconomics, I'm not a really big fan of doing supply and demand, which is why I generally avoid it on exams. But it will show up in some of your quizzes online. Now, what the quantity theory of money is essentially saying is that it's essentially showing us the velocity equation, but we are actually keeping the real GDP constant as well. So it's showing the relationship between the money supply and the price level. We see on the left-hand side of this graph, we've got the value of money, 1 over P. How much does money cost? 1 per dollar. Right? So that's how we can interpret that. And then on the right side, we have the price level. And notice that the price level decreases as we go up the axis. What this is showing us when it comes to the money demand, that as that price level increases, so we're moving down along the right side of the axis, if the price level is increasing, then people will demand to hold more money. So the quantity of money demanded will increase. Why? Well, the price level is telling us about the prices of goods and services in the economy. If a sandwich is $5, well, you only need $5 in your pocket. But if a sandwich is $10, then you need $10 in your pocket. So notice how you want more money in your pocket, i.e. the quantity of money demanded is greater when the prices are greater. And when we increase the money supply, we see that the price level increases. The value of money goes down. Right? There's a lot more money in the economy. Is money as valuable? No. The price of money on the left-hand axis is going down. And the price level is going up. Right? We've got more money per basket of production, more dollars per basket. That price of everything in the economy has gone up. The Fisher effect is the other part of the classical dichotomy. The Fisher effect has to do with real interest rates and nominal interest rates. Nominal interest rates are equal to the inflation rate plus the real interest rate. This first equation is what the banker might use. So the banker is going to say, how much interest should I give customers who deposit their money? Well, customers are going to want a real return on their money. A real return is about being able to purchase more real goods. So if we deposit our money for 1 year, I would expect that I can actually buy more real goods at the end of the year than I could at the beginning of the year. Which means that the growth in my money, nominal interest rate is about how quickly my money grows. The growth in my money is going to have to be accounted for by both the inflation rate and give me a real return. Think about it for a second. I deposit $100 in the bank, and the banker says, I am going to give you a 10% interest rate. Imagine if the inflation rate was also 10%, which means that if I have $100 today, and apples cost $1 per apple, I can buy 100 apples. But in a year from now, I've got $110. But apples are now $1.10 because inflation was 10%, which means I can still buy 100 apples. So the real interest rate in that case is 0. Because I cannot buy any more goods. So I want my money to grow faster than the inflation rate. And if that's the case, then I can actually buy more goods at the end of the year. So the banker is going to set that nominal interest rate. And that banker is going to set that nominal interest rate based on expected inflation and the real interest rate, which is fairly constant, although it does vary year to year. The equation that I am going to use as a depositor is going to be the second equation. So at the end of the year, I want to be able to determine my real interest rate. So let's just set up a new example. If the nominal interest rate was 10%, and the inflation rate was 5%, then that means that the real interest rate for me at the end of the term was 5%, which is telling me that I can actually purchase 5% more goods. So my money grew faster than prices grew, and now I can buy more real goods. That is the real interest rate. And here we have some data on the history of Canada from 1965 to 2012. The blue line is going to be is the nominal interest rate. The yellow line is the real interest rate, which means that the difference between the nominal interest rate in blue and the real interest rate in yellow is inflation. And notice how big inflation was in the 70s and moving into the 80s and then moving, even into, I guess just the 70s and 80s really. So during this time, the inflation was very, very high. Now imagine, let's just look at that 1980 value. That's the peak. We can see a nominal interest rate up at about 18%. Can you imagine your money growing at 18% just in a savings account? That is very, very high. But look at, we've got a 6% real interest rate during that time, which means that inflation in 1980 would have been, 18 minus 6, which gives me 12%. But imagine that you actually purchased a government bond. Let's imagine that you purchased a 10-year government bond, and that 10-year government bond is paying an interest rate of, it's going to pay an 18% nominal interest rate. Every year, you're getting 18% nominally on that bond. As we move to 1990, notice that the difference between the blue and the yellow is only about 5%. That means inflation is 5%. Now, I've got a 10-year bond, and every year it's giving me an 18% return. Which means that in the first year, 1980, I'm only getting a 6% return, 18 minus 12. 18 nominal minus 12 inflation. But when I move to 1990, if there's a 5% inflation rate, I'm getting an 18% nominal return minus 5% inflation, which means that I'm getting a real return of 13%. That's a pretty good real return. That's better than the stock market. So people who bought long-term bonds in the 1980s actually did quite well when it came to the 90s, or even into the mid-80s and the late 80s. So notice how the Fisher effect is important when it comes to purchasing bonds or depositing your money. High inflation does create costs for society, so let's look at some of those costs. The first one is just called the inflation tax. This is the general concept of inflation. It just means that when you have money in your pocket, if you have any sort of savings, and you've just got that, and the government starts printing money. Right? Maybe it's the central bank, through the request of the government. But ultimately, we'll just call it the government for now. But I should mention that the government and the central bank are separate entities. They're separate institutions. The government does not control the central bank. They actually make decisions somewhat independently. Sometimes they cooperate, but they are independent institutions. But getting back to the inflation tax, if money is printed, it basically means that there's going to be higher inflation rates. And this means that the money in your pocket is losing value. So the government isn't taxing you directly. How they're doing it is they're basically creating money for themselves, which is ultimately going to tax you through inflation, i.e. by reducing the value of the money you have in your pocket. So that's kind of the big overarching picture for printing money. But there are some other specific costs that we can talk about. The first is shoe leather costs. What are shoe leather costs? Well, they're having to do with buying new shoes or fixing your shoes. When inflation is high, you do not want to have a lot of money in your pocket. you would rather have that money in a savings account in the bank. Because remember, your savings account is going to have a nominal interest rate, which is equal to the inflation rate plus the real interest rate. The most important part of that is that the inflation rate is going to be included in your nominal interest rate. So your money will be growing if it's in the bank. But if it's in your pocket, it will not be growing, which means that you do not want to have a lot of money in your pocket. Let's just imagine a case where, the prices of something are just going up. Sandwiches. We'll just assume that they're going up a lot. Today a sandwich is $5, but inflation is high. So I'm going to take $5 out of the bank and I'm going to run to that sandwich shop and I'm going to buy that sandwich for $5. Awesome. I can feed myself. The next day I want to buy a sandwich again, but because of inflation, the sandwich price has gone up to $6. So I'm going to go to the bank. Now I did have $5 in my bank account yesterday, but today that $5 is $6 because the nominal interest rate has basically increased the amount of money in my bank account. So I can pull out that $6 and I can run to the sandwich shop and I can buy myself a sandwich. So your money in the bank is keeping up with inflation, but the money in your pocket is not. So you want to keep money in the bank and only take out the minimum amount when you want to buy something. All of this work running back and forth to the bank means that you wear a hole in your shoes and you got to buy new shoes. That is shoe leather costs. Now that's just an anecdote, but in today's society, it means that you need to spend a lot more time managing your money, all right? So even in a computer system, computer times here, it means that you're going to have to, get on the computer and pull money out of your savings account and put it into a deposit account, and you're going to have to pull money out and get cash and make sure that you've got it. Yeah, it's just going to take a lot of work. Those are also shoe leather costs, although a little bit of a different, but it's about the inconvenience of managing your money. Shoe leather costs are about inconvenience of managing money. Menu costs. If you own a business, you need to change your prices more often if there's inflation. If prices of everything have gone up 10%, but you haven't changed your own prices yet as a business owner, well, then you're not going to be earning as much profit. So you've got to change the prices on your menus. And again, even in today's modern times where you think, oh, but there's nothing to change. You just, scan your barcode across the scanner and it goes beep and then a price pops up. But there's somebody who has to scan that barcode and type it into a computer. That's taking man hours, right? Labor hours are required to do that. So instead of somebody working on something more, to help the business grow, what they're doing is they're getting paid to change prices. Relative price variability and resource misallocation. So when people change their prices, they've got to change them quite a bit. Again, we can think about a fairly high inflation rate. 10% inflation. Imagine that there is a banana farmer and an apple farmer. And, inflation is at 10%. So what are these farmers going to do? Hey, I'm the apple farmer. I'm going to raise my prices by 10%. Oh, notice how the apple farmer has changed their price by 10% before the banana farmer did. So the apple farm, the apples go up 10% in price. So what are people going to do? Well, they're going to switch to eating bananas because they're relatively cheaper. Now, they really shouldn't be, right? I mean, hopefully the prices go up at the same time. But ultimately, because this apple farmer has raised their prices sooner and also a fairly high margin, the higher the inflation, the worse this will be, there's going to be people who actually start to buy bananas instead of apples. So that's the resource misallocation. If inflation were low, then we would only see a 1% increase in the apple price. And people aren't going to notice that as much. So we're still going to be at that, at that real relative price, which is generally constant over time. But when there's high inflation, the real relative prices are not as constant. Inflation-induced tax distortions. We'll actually do an example of this at the end of the lecture. But what I can tell you is that the higher the inflation rate, the lower the real return on your investments will be after taxes are accounted for. And it's because the government taxes nominal gains. It doesn't tax real gains. The government taxes money. The government taxes nominal gains. That's the reason why we have these tax distortions. So, one more time, your after-tax real return, is going to be lower when we have high inflation compared to low inflation. And then there's a lot of confusion and inconvenience. When there's high inflation, it's hard to do business, especially if you have long-standing orders. How much am I going to pay for this product, 5 months down the line, 2 years down the line? I mean, some projects, they actually start ordering their materials years in advance. If Boeing is going to build a jet plane, they're actually ordering their aluminum a couple years in advance. And they're saying, we need this on this date. Well, if there's high inflation, it's very difficult to negotiate prices. And when there's unexpected inflation, there's redistribution of wealth. This has to do with the Fisher equation. Remember, the nominal interest rate is going to be based on expected inflation. But what if inflation is not as expected? What if it's higher than normal? Well, if it's higher than what was expected, then you can look at your equation right now. If inflation is higher than expected, then that means that the real interest rate is going to be lower than expected. What this means is that if you borrowed money, you're doing better. But if you've deposited money, if you're a saver, then you're not doing as well. So if the inflation rate is higher than expected, borrowers win and savers lose. And if the inflation rate is lower than expected, then savers win and borrowers lose. Hyperinflation is when money is printed out very, very quickly. And this happened a lot in World War I or just after World War I as countries needed to pay off their debts. So some of these countries, they simply just printed money, right? So they go over to the printing press literally and print off money. Imagine if you could do that. You borrow $100 from your friend, and then you can just go home and on your own printer, imagine that you could just print off a $100 bill and then give it back to your friend. I mean, that's exactly what is happening here. But of course, this is going to increase the money supply. We can see the first graph with Austria. We can see that Austria started off at a price level of 100. And we see that that price level between 1921 and 1923, so just in 2 years, the price level increased to 10,000. So 10,000 divided by 100 is 100, which means that the prices increased 100 times. So let's think about that. Look at that price level in 1921. Yeah, it is 100. That means I can buy something for $100. But that same good in 1923 is going to cost me $10,000. We can see Hungary was involved as well. In 1921, I could buy something for $100. And then in 1924, that same good would cost me about, this looks like a logarithmic scale, would cost me about $80,000. And Germany was the worst offender. You could buy something in 1921 and 1922 as well for about $100. And then about halfway through 1922, they started firing up those printing presses. And they fired them up so much that the price level went from 100 all the way up to 1 with, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 zeros. Trillion. That's 1 trillion. So something that cost me $100 in 1922, 2 years later in 1924, would cost me $1 trillion. I'm just going to do a quick calculation to put it in even more perspective here. We've got 365 days per year. 2 years is 730 days. So I'm going to take 1 trillion I'm going to divide it by 100. So I've got 1 exponent 10. 1 times 10 to the 10. So I think that's 10 billion. And I'm going to divide it by the number of days, 730. And wow, I mean, even that's a big number. So prices on a daily basis were going up 13 over 13. Well, what is it? 13.7 million times. So something that cost me $1 at the beginning of the day would cost me $13.7 million at the end of the day. That's how quickly they're printing money. Amazing. And we also saw this more recently in Zimbabwe. Right? So 3 eggs. You gotta carry around a $100 billion bill. So, yeah, there's a lot of money being printed. Looks like this individual would like to buy a couple loaves of bread. And notice, there's no armored truck there because this money isn't really that much. Right? And here we see money being used as wallpaper. So it's so worthless. You know, if you were going to take all of this money to buy wallpaper, it would cover less of the wall. Right? So it's better just to cover the wall in money. So what did we learn today? Well, we learned that the printing of money causes long-run inflation. And we also learned that inflation imposes costs on society. So I got my images from Pixabay. So thank you for Pixabay. This is a place where you can get free images. Thank you for listening to this lecture. Hope you learned something. Take care, everybody.